In this video, we will be solving questions 9, 10, 11, and 12 from the new syllabus Mathematics Book 2, 7th edition, chapter number 2, exercise 2F. Question number 9. The figure shows a rectangle with its length and breadth as indicated. Given that the perimeter of the rectangle is 120 centimeter, find the area of the rectangle. Take a look at this figure. It's a rectangle with dimensions 3x negative y centimeter, 2x negative 3 centimeter, and 2x plus y centimeter. First, let me define this geometrical shape. A rectangle is a quadrilateral with equal and opposite sides and 4 right angles. Since the opposite sides are equal in measurement, we can take the lengths of the upper and lower sides, and I'll name this equation as equation 1. So 2x positive y equals 3x negative y. So these two lengths are equal in measurement. Therefore, we can write them as 2x positive y, which is the length of the lower side, equal 3x negative y, which is the length of the upper side. I'll name this equation as equation 1. It is also stated in the statement that perimeter of the rectangle is 120 centimeter. Since perimeter is defined as the total distance covered by its boundaries or the sides, therefore I'll take the sum of all the sides of the rectangle equal to 120 centimeter, which means length of the first side 2x negative 3 plus opposite side 2x negative 3 plus upper side 3x negative y plus opposite side to the upper side 2x positive y equals 120 centimeter. I'll name this equation as equation 2. The task is to determine the values of the variable x and y. To begin, I will solve equation 2 by simplifying the parentheses. This will result in 2x negative 3 plus 2x negative 3 positive 3x negative y positive 2x positive y equals 120. As we know, a positive sign before parentheses will not affect the values inside the parentheses. So I'm going to write them as they are. In this equation, positive 2x, positive 2x, positive 3x, and positive 2x, they are like terms. So their total sum is 9x. Negative 3 is negative 6. Positive y and negative y will cancel each other out. So we get 9x and negative 6 equals 120. To solve this equation for x, I'll add 6 to the both sides of the equation. This will result in 9x negative 6 positive 6 equals 120 positive 6. Now positive 6 negative 6 is 0. We get 9x equals 126. Next, I'll divide both sides of the equation by 9. We get x equals 14. Now that we have determined the value of the variable x, we can proceed to find the value of the variable y by substituting the value of x into equation 1. Equation 1, 2x positive y equals 3x and negative y becomes 2 into 14 positive y equals 3 into 14 negative y. Next, 14 times 2 is 28 plus y equals 14 times 3, 42 negative y. To solve for y in this equation, we can either add or subtract y from both sides. I'm going to add y, which will result in 28 positive y equals 42 negative y positive y. 28 positive y and positive y, they are like terms, so their sum is 2y equals 42. Next, I will subtract 28 from the both sides of the equation. We get 2y equals 14. Now, I'll divide both sides of the equation by 2. We get y equals 7. Now we have found the values of the variables x and y. Now it's time to find the area of the rectangle. As we know that area of the rectangle is equal to the product of its length and breadth. I'll take length of the rectangle as 3x negative y and breadth of the rectangle as 2x and negative 3. If we substitute the values of the variable x and y, we get 3 into 14 negative 7 times 2 into 14 negative 3. Next, 14 times 3, 42 negative 7 times 14 times 2, 28 negative 3. Subtracting 7 from 42, we get 35, and subtracting 3 from positive 28, we get 25. And their product is 875 square centimeter, which is the total area of the given rectangle. Question number 10. The figure shows a rhombus with its sides as indicated. Find the perimeter of the figure. Now before solving this question, I'll define a rhombus. This geometrical shape is defined as a quadrilateral that has all four sides equal in length. Now let's solve this question. Since all sides of a rhombus are equal in measurement, therefore I'll take the length of the side 2x positive y positive 1 centimeter to be equal to the length of the side 3x negative y negative 2 upon 2 centimeter. And I will name this equation as equation 1. Now, I'll take the length x negative y centimeter to be equal to the length 2x positive y positive 1 centimeter. Now, I will name this equation as equation 2. The question arises as to why we don't consider the length x negative y centimeter to be equal to the length of the fourth side. The answer is that we can consider these two lengths to be equal, but we are not given the length of the fourth side based on the given condition in terms of x and y. Furthermore, we also don't know the length of the side of the rhombus. After labeling these two equations as equation 1 and equation 2, we have constructed a system of linear equations, and we are familiar with the various methods for solving such system, including the substitution method and the elimination method. Therefore, we can use these methods to solve equation 2. I'll solve this equation for the variable x. Therefore, I'll subtract x from both sides. We get x positive y positive 1 equals negative y. To simplify further, I'll subtract y and 1 from both sides of the equation. We get x equals negative 2y negative 1. I'll label x equals negative 2y negative 1 as equation 3, and I'll substitute this equation into equation 1. Now, equation 1, 2x positive y positive 1 equals 3x negative y negative 2 upon 2 becomes 2 into negative y and negative 1 positive y positive 1 equals 3 into negative 2y negative 1 negative y negative 2 upon 2. Now 2 times negative 2y is negative 4y, 2 times negative 1 is negative 2. On the right side, 3 times negative 2y is negative 6y, and 3 times negative 1 is negative 3. Negative 4y positive y is negative 3y. Negative 2 positive 1 is a negative 1. On the right side, negative 6y negative y is negative 7y, and negative 3 negative 2 is negative 5. Now to eliminate 2 from the right side, I'm going to multiply both sides of the equation by 2. We get 2 times negative 3y negative 6y, 2 times negative 1 negative 2. On the right side, 2 will cancel out 2. We get negative 7y negative 5. To simplify further, I will add 7y to both sides of the equation. We get y negative 2 equals negative 5. And now let's add 2 to the both sides of the equation. We get y equals negative 3. Now we have found the value of y. To find the value of x, let's substitute y equals negative 3 into equation 3. Now equation 3, x equals negative 2y negative 1 becomes x equals negative 2 into negative 3, negative 1. Now the product of negative 2 and negative 3 is positive 6, and the difference between positive 6 and negative 1 is positive 5, which is the value of x. Now that we have found values for both variables x and y, let's proceed to find the perimeter of the rhombus. Perimeter of the rhombus is equal to 4a. The perimeter of a rhombus can be calculated by multiplying the length of one side, represented by a, by 4. Once you find the length of a side of a rhombus, you can find its perimeter by multiplying this length by 4. I'm going to do the same thing. I'll take any side of the rhombus denoted as x negative y centimeter and substitute the values of the variables x and y into this expression. We get 4 into 5 negative times negative 3. Negative times negative is positive. 5 positive 3 is 8, and 8 times 4 is 32 centimeter, which is the total perimeter of the rhombus. Therefore, perimeter of the rhombus is 32 centimeter. You can substitute the values of the variables x and y in the expressions 2x positive y positive 1 centimeter or 3x and negative y negative 2 upon 2 centimeter, and the result will still be 32 centimeter. Question number 11. If 1 is subtracted from the numerator and from the denominator of a fraction, the value obtained is 1/2. If 1 is added to its numerator and to its denominator, the resulting value is 2/3. Find the fraction. Since we don't know the required fraction, I'm taking the numerator of the fraction as x and the denominator of the fraction as y. As stated in the statement, if 1 is subtracted from both the numerator and the denominator, the value obtained is 1/2. Therefore, we can write the fraction as x negative 1 upon y negative 1 equals 1/2 or 1/2. Now, if 1 is added to the numerator and denominator, the resulting value is 2/3. Therefore, we can write the fraction as x positive 1 upon y positive 1 equals 2/3. I label these two equations as equation 1 and 2. We have a system of linear equations that can be solved using either the elimination method or the substitution method. I'll be using the substitution method to solve the following system. Therefore, from equation 1, which is x negative 1 upon y negative 1 equals 1 upon 2. By cross multiplication, we can write this equation as 2 into x negative 1 equals 1 into y and negative 1. The next step is to simplify the resulting expression. We get 2 times x, 2x, and 2 times negative 1 is negative 2 equals, if we multiply y negative 1 by 1, we get the same expression y negative 1. To solve this equation for y, I'm adding 1 to both sides of the equation to eliminate the negative 1 from the right side. We get 2x negative 1 equals y. I label this equation as equation 3. Since we are solving the system of linear equations by substitution method, therefore I'll substitute y equals 2x negative 1 into equation 2. Equation 2, x positive 1 upon y positive 1 equals 2 upon 3 becomes x positive 1 upon 2x negative 1, which is the value of y, positive 1 equals 2 upon 3. Negative 1 positive 1 equals 0. We get x positive 1 upon 2x equals 2 upon 3. Using cross multiplication, we can write this equation as 3 into x plus 1 equals 2 into 2x. Now, 3 times x is 3x, and 3 times 1 is 3. On the right side, 2 times 2 is 4x. To solve this equation for x, I'll subtract 4x from both sides of the equation. We get 3x positive 3 negative 4x equals 4x negative 4x. Now 4x negative 4x is 0. On the left side, positive 3x negative 4x is negative x. Now, in the next step, I will add positive x to the both side of equation. We get negative x positive 3, positive x equals positive x. This will result in 3 equals x or x equals 3. Now that we have found the value of the variable x, to find the value of the variable y, I will substitute x. Equation 3 with negative 1 equals y becomes 2 into 3 negative 1 equals y. Now 2 times 3 6, 6 negative 1 equals 5, or y equals 5. We have determined the values of the variables x and y, which represent the numerator and denominator of the fraction needed. Therefore, the required fraction is 3 upon 5. Verification. We can verify the solution by performing some calculations. The fraction we have determined is 3 upon 5. If we subtract 1 from both the numerator and denominator of the fraction 3 upon 5, the result is 1 upon 2, which satisfies the first condition of the question. Additionally, if we add 1 to both the numerator and denominator of the fraction 3 upon 5, we get 2 upon 3, which satisfies the second condition of the question. It is important to note that verification is done for clarification purpose. Question number 12. Another question where we have to find some unknowns. The ages of pandas. We will solve this question using a system of linear equations. The statement of the question is as follows. The giant pandas, Kai Kai and Jia Jia, reside at the river safari. The sum of their ages when they first arrived in Singapore in 2013 was 11 years. In 2022, Kai Kai will be 3 times as old as Jia Jia was in 2013. Find their ages in 2014. Now, we don't know their ages. So let's take the age of Kai Kai in 2013 as X and the age of Jia Jia in 2013 as Y. According to the first condition of the question, the sum of their ages is 11 years in 2013. So we can write the equation as x plus y equals 11. The second condition states that in 2022, Kai Kai will be 3 times as old as Jia Jia was in 2013. So we can write the equation as x plus 9 equals 3y. It is important to note that the difference between 2013 and 2022 is 9 years. So the age of Kai Kai, which is x plus 9, will be 3 times the age of Jia Jia, which is 3y. I label these two equations as equation 1 and equation 2. As you can see, a system of linear equations is evident in the given problem. This system can be solved using either the elimination method or the substitution method. In this case, we will solve the system using the elimination method. To do this, we will subtract equation 2 from equation 1. So, left-hand side of equation 1, which is x plus y, and left-hand side of equation 2, x positive 9 equals 11, which is the right-hand side of equation 1, negative sign 3y, which is the right-hand side of equation 2. Next, I'm going to multiply this negative sign by positive x and positive 9. So we get negative x, negative 9. As you can see, positive x and negative x will cancel each other out. We get y negative 9 equals 11 negative 3y. I'll add 3y to both sides of this equation to eliminate negative 3y from the right side of this equation. We get 4y negative 9 equals 11. Now, let's add 9 to both sides of this equation because I want to eliminate negative 9 from the left side. So we get 4y equals 11 plus 9, 20. To solve this equation for y, we will divide both sides by 4. So we get y equals 5 because 4 times 5 is 20. Now, to find x, we will substitute y equals 5 into equation 1. Equation 1, x plus y equals 11 becomes x plus 5 equals 11. Since we are solving this equation for x, so I will subtract 5 from both sides. We get x equals 6. Now that we have found the values of the variables x and y, which means we have found the ages of Kai Kai and Jia Jia in 2013. Therefore, age of Kai Kai, it's Kai Kai, K-A-I. In 2013 is 6 years, and age of Kai Kai in 2014 means that 6 plus 1 equals 7 years. And age of Jia Jia in 2013 is 5 years, and in 2014 age of Jia Jia will be 5 plus 1 equals 6 years. Now verification. Since age of Kia Kia in 2013 is 6 years and age of Jia Jia in 2013 is 5 years, after 9 years, means in 2022, age of Kia Kia will be 6 plus 9 equals 15 years. Since 15 is 3 times of 5 and 5 was Jia's age in 2013, it is clear that after 9 years in 2022, Kia's age will be 3 times that of Jia's age in 2013 because 15 is 3 times of 5.